This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. Never cover a frame merely because the carpentry looks finished. I treat the framing inspection as the last complete view of the building's structural skeleton after the rough mechanical, electrical, and plumbing work has had every chance to cut, drill, or interfere with it. That timing is the heart of inspection readiness. The structure must be complete enough to judge, the rough systems must already be inspected and approved, and the work must still be open enough to see. That creates a narrow but important window. Too early and later trade work can change the frame after the inspector leaves. Too late and insulation or wall covering hides the evidence. A general B contractor protects that window through sequencing, not luck. California's frame inspection sequence starts with a simple rule. The roof deck or sheathing, the framing, the fireblocking, and the structural bracing must be in place. The rough electrical, plumbing, and mechanical systems must already be inspected and approved before the frame inspection is conducted. I want the order to be unmistakable. Framing does not receive its final open wall review and then invite the rough trades to begin cutting. The rough trades finish first, their required rough inspections are approved, and then the framing inspector gets the whole picture. Imagine a contractor who checks a bearing wall on Monday and sees clean, untouched studs. On Tuesday, a plumbing crew routes a large waistline and removes too much material from several studs. The wall that looked acceptable on Monday is not the wall that exists on Tuesday. The frame inspection belongs after that alteration because the inspector needs to evaluate the final visible condition, not an earlier version of it. Looking at this sequence, I begin with the approved documents at the site. I confirm the structural frame, roof sheathing, bracing, and fireblocking are complete. I then confirm the rough mechanical, electrical, and plumbing work is complete and that the required rough approvals are recorded. I keep every inspection item exposed, request the frame inspection under the local procedure, and wait for approval before moving into work that conceals the cavities. This sequence also protects the schedule. A failed frame inspection does not stay in the framing lane. It can hold the insulation crew, the drywall crew, the taper, the painter, and the finish work behind them. That is why I treat readiness as a coordination task across trades rather than a carpenter's punch list. I also separate statewide construction requirements from local administration. California establishes what must be ready and what must remain visible. The local building department may control request methods, notice periods, access instructions, and forms. I verify those local procedures rather than inventing a statewide deadline that does not exist. Visibility means more than leaving a few wall bays open. The inspector needs an unobstructed view of the work that is being approved. That includes the framing members, roof deck or sheathing, structural bracing, fireblocking, sheathing fastening, anchor bolts, hold downs, connectors, and the cuts or holes made for rough systems where those items apply to the project and approved plans. I do not allow insulation or drywall to cover those conditions before approval. California inspection rules require work to remain open until the required inspection occurs and approval is given. A photograph may help document the project, but I never assume a photograph replaces the enforcing agency's required inspection or authorization to conceal. Consider a hypothetical accessory dwelling unit with a compressed schedule. The electrical rough work is complete and the drywall crew has an opening. The tempting decision is to hang board now and rely on photos later. That shortcut changes a visible inspection into a guessing exercise. Fireblocking, fastener patterns, hardware, and trade alterations become difficult or impossible to verify in place. The likely result is correction work and removal of covering materials so the concealed conditions can be inspected. The practical lesson is not complicated. I keep the work open. I keep access reasonable. and I remove stored material that blocks critical walls or hardware. Those housekeeping choices do not replace code compliance, but they make the compliant work inspectable. The frame can be physically perfect and still be unready if the job site documents are missing. I keep the approved construction documents at the site, along with required engineering calculations, deferred submittals or truss information when they apply, and the official inspection record card. The documents must be available to the inspector. The inspector is comparing the built condition with the approved condition. That comparison cannot be performed reliably from memory, an unapproved field sketch, or a set of plans sitting in the contractor's office. I treat the stamped set as a working control document, not a permit souvenir. If a field change affects framing or hardware, I do not assume a red pencil note makes it approved. I follow the applicable process for revised approval, engineering, or direction from the authority having jurisdiction. The exact process can vary, but the supervision principle stays the same. The work in the wall must match an approved basis. I also check that prior, rough approvals are actually documented. Hearing that a subcontractor is finished is not the same as confirming that the required rough inspection was approved. I look at the inspection record and the jurisdiction's accepted record system before I schedule the frame inspection. Rough systems create the most common structural questions because pipes and wires need pathways. The California Residential Code places different limits on notches depending on the stud's role. An exterior or bearing wall stud may be notched no more than 25% of its width. A non-bearing stud may be notched no more than 40%. A bored hole may be as large as 60% of the stud width, and the edge of the hole must remain at least 5/8 inch from the edge of the stud. The comparison is easier when I separate notches from bored holes. For notches, the wall type changes the limit. Bearing and exterior studs receive the smaller allowance. Non-bearing studs receive the larger allowance. For bored holes, the stated maximum is 60%, paired with the 5/8 inch edge distance. I never turn these percentages into permission to improvise around an engineered condition. Approved plans, engineering details, and other code provisions can control a specific assembly. These numbers are the prescriptive inspection checkpoints supported by the residential code material in this lesson. Suppose a crew cuts a notch through about half the width of a bearing wall stud for a waistline. That is not a close judgment call under the stated prescriptive limit. I stop concealment, identify the affected members, and obtain an approved correction, rather than assuming that a scrap sister or a metal shoe automatically solves the problem. The memory connection is simple. A bearing stud carries more responsibility, so its notch allowance is the tighter one. I remember 25 for bearing and exterior, 40 for non-bearing, then 60 for a bored hole with 5/8 left at the edge. Fireblocking is another item that becomes nearly useless to inspect after the wall is closed. In combustible construction, fireblocking cuts off concealed draft openings. It is installed at floor and ceiling levels and horizontally at intervals not exceeding 10 feet where the code requires it. Openings around pipes and wires must be blocked or sealed with approved material. The physical effect matters. An open stud cavity can give hot gases and flame a concealed route through a building. A tight fireblock interrupts that hidden passage. That does not mean every piece of wood shoved into a gap qualifies. The code recognizes specific materials and methods, and penetrations need an approved material that closes the annular space around the item passing through. I look for continuity, tight-fitting installation, and missed openings at floor and ceiling lines, at required horizontal intervals, and around pipe and wire penetrations. I also compare the installation with the approved documents and the applicable code. The purpose of my field walk is to find the open path before the inspector does, while the correction is still simple and visible. A common mistake is treating fireblocking as cosmetic scrap work. It is not there to make the cavity look full. Its value depends on whether it actually blocks the concealed opening. Loose pieces, open edges, or an unsealed ring around a pipe can leave the route that the fireblocking was supposed to interrupt. California framing inspection also focuses heavily on the connection from the wood frame to the foundation. Anchor bolts are generally placed no more than 6 feet on center, with at least 2 bolts in each plate section, and a bolt no more than 12 inches from each end of the sill plate under the stated residential provisions. Within a braced wall line, the anchor bolt washer is not a casual hardware choice. The cited California residential provisions require a steel plate washer at least 3 inches by 3 inches by 0.229 inch. A standard round cut washer does not provide the required plate size for that condition. I use this hardware reference as a field check. Then I return to the approved plans because a project may require closer spacing, different hold downs, or an engineered connection. The chart shows the prescriptive maximum spacing and end placement for anchor bolts, the minimum count per plate section, and the minimum plate washer size for bolts within braced wall lines. The plate washer spreads force over a larger area of the sill. Under lateral and uplift demand, that larger bearing area helps keep the nut and washer from crushing or splitting through a narrow portion of wood. The hardware is small compared with the wall, but it sits in the path that carries force from the braced wall into the foundation. I trace that path during my walk. Roof and wall sheathing transfer forces through their fasteners into framing. Braced wall panels connect through straps, hold downs, anchor bolts, and sill plates into the foundation according to the approved design. A missing connector, an obstructed hold down, an incorrect washer, or fastening that does not match the approved schedule can interrupt that path. Sheathing nails deserve the same disciplined review. I compare nail type, placement, edge spacing, and field spacing with the approved plans and applicable fastening schedule. I do not memorize one universal spacing and apply it to every wall. The required pattern can depend on the assembly and design. I also watch for overdriven fasteners that damage the panel face, because that condition can reduce the intended connection and may require correction. Before I call for the inspection, I make one final pass in a fixed order. I start with the paperwork. Approved plans, required engineering information, deferred submittals, and the inspection record must be present and available. Then I look at a completeness. Roof deck or sheathing, wall and roof framing, bracing, fire blocking, and required structural hardware must be installed. I verify that the rough mechanical, electrical, and plumbing work is complete and that the required rough approvals are recorded. Next, I follow the damage trail. I inspect the large pipe roots, repeated wire bores, and any place a trade altered a stud or other framing member. I compare notches and holes with the applicable limits and approved details. I do not hide a questionable cut behind insulation and hope it disappears. Then I follow the load path. I check sheathing fastening against the plans, confirm anchors and plate washers, look at hold downs and connectors, and make sure the inspector can see them. I finish with fire blocking and penetrations, looking for an open, concealed path. Finally, I stop the cover crews. No insulation and no drywall until the required frame approval is in place and the next inspection sequence is confirmed. That last pause is not lost time. It is what keeps a small correction from becoming demolition. Based on the published CSLB study outline, this kind of inspection readiness falls under testable framing and project coordination material. The most useful memory line is this: rough systems approved, structure complete, documents on site, everything visible, then frame inspection, then cover. I made an audio practice quiz for this specific episode so you can work the inspection sequence. Visibility rules, stud limits, fire blocking, and hardware checks from memory. It is audio-based with the questions read aloud and your answer made by tapping, because I know you may be studying while driving, working, or moving between jobs. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about what I covered, and subscribe so I can help you stay on track through every episode until you get your license. I am rooting for you, and I want the next inspection decision you study to feel clearer than the last one.